This is the SIG network meeting for April 28th, 2022. Do we have a triage lined up for today?
I do. There's only one issue to even look at.
Perfect.
All right, give me a moment. Share window. This one.
The contract one.
Sorry, say again?
I know. I thought that was the one related to contract. Yeah.
Oh, no, I mean, there are a bunch open, but people have been asking questions on them, so we don't need to discuss them here, I think. The only one that I thought was worth discussing here was this one, which Cal opened. Cal, I don't know if you're here.
Sorry, Cal wasn't able to make it today.
No problem. He's merely asking the question of what is the intention of the load balancer source ranges field. I thought if he was here, we could discuss it, but there's discussion in the bug, so maybe we'll just leave it there.
Yeah, but I don't understand the concern of the scalability of the problem.
I mean, I think if you put 1,000 of these things in there, then you're going to write 1,000 IP tables rules, which, you know, isn't that many, all things considered.
Yeah, but that
Will
applies.
you overflow the JSON object?
Right.
That's more likely to be a problem first.
But the same applies to labels or to annotations. I mean.
Yes, agree.
Yeah,
so I think you're more likely. So I think there was two problems. One, Cal thinks it's underspecified, which maybe the text of it is, but it is being validated. And the second part of it is, what's it like? Should we be programming IP tables with it? I think the answer is yes, and I don't see it as problematic. Maybe we can fix the comments around it, but I don't think there's any path where we get rid of it. I mean, aside from the fact that it's a GA field, so. Okay, that's it for triage then.
Cool. I think the item on here, but from Jay was actually from me, based off of discussion from last time, but Jay's not here, so we can skip over that. Bridget and Tim are planning to be out and not on this call on May 12th.
That's right. You guys are welcome to have the call anyway, or we can cancel it. It being the day before, or the week before KubeCon, many people will be traveling.
People might be traveling, especially if they're participating in like pre-event, contributor summit, etc. stuff, but just letting you know.
Yep, I'd be fine canceling it, and then we can just have an extra juicy post-KubeCon meeting. So I'll do that. And then we've got Alexander to discuss Kube Controller Manager.
Yeah. So I linked the presentation in the doc. You can either follow along over there, or I'll just try to share my screen quickly. I don't really zoom that often, so hopefully this will work. Okay, I hope you can see my screen. If not, tell me. So essentially, I would like to talk about the Cloud Controller Manager, and specifically at scale. So I'm kind of working on a project right now where we have a many-to-many relationship between LBs and cluster node, which isn't really all that common in the normal cases. But in this case, it's something that is being used in this project. And we are encountering a couple of issues with regards to the sync, time to sync by the Cloud Controller Manager. And what we're seeing is this is mainly happening on large clusters where nodes transition from a not ready to a ready or back and forth state. And so having looked at the implementation of the Cloud Controller Manager, and especially at sync loop for the nodes, I'm seeing that we sync all load balancers for each node event, so to speak, so whenever it transitions. And this is causing a specific corner case to trigger outages by clients which are trying to connect to these LBs. And I just wanted to quickly present this I already filed a PR, which kind of fixes it. Obviously, I'm looking forward to getting your input on that and maybe reaching a consensus. But the idea is essentially this. So in this case, we can imagine that we have 5 load balancers, each of which are using external traffic policy local. So they're only pointing to one node. And one of these nodes transitions from not ready or ready to not ready, which will cause all of these load balancers to get updated. Now, the toil here on the cloud provider side might lead to the fact that the delta between, so the duration to sync all of these load balancers is, if it's greater than the delta for the node to transition from not ready to ready again, that increases the duration of the experienced outage by the client. So I detailed this a bit better in my PR, and that kind of maybe exemplifies things. So whenever people get a chance to have a look at that, please do. And essentially what the idea is here is that for external traffic policy, local type of services, whenever a node transitions from not ready to ready, if that node isn't actually hosting the endpoint for that service, it's not really impactful for that service. So there's no real reason in actually updating that load balancer. Like I said, this is in this specific corner case with a many-to-many relation. And for external traffic policy local. Now, there's a second problem as well, which is mainly with regards to applications which are high intensity, as I call it, or low latency, which kind of can reduce the problem to the kubelet. An example of this is, for example, if a service, so the pod servicing acting as an endpoint to the service, gets a burst of increased number of transactions per second, for example, this can increase the CPU and memory consumption on the node, hence leading the node's resources to get a bit starved. The kubelet could have difficulties keeping up, marking the node not ready, causing the CCM to remove the node from the backend pool from the LB, and hence having the client experience an outage, even though the app might be able to keep up with this increased load. An application that follows this type of a deployment model doesn't really want to impose resource limits because that might impact service SLAs, either in terms of the memory that is being used or the CPU at any given moment in time. Right? So I have a couple of proposals for this. I just wanted to present them in this meeting just to get people's kind of opinion on it. But obviously, I guess the greater discussion will be maybe on that PR. So the first proposal and the thing I implemented in point number 1 is that for services ETP local do not sync whenever a node transitions state from not ready to ready and back and forth if the node doesn't host the service endpoints. Because as I mentioned, if that is the case, it doesn't really impact that LB. It's a bit of a moot point for it. The second point is for all services, do not sync node transitioning state. Because the reasoning behind this was more that node readiness doesn't really have a direct correlation to whether the endpoint is accessible or not. There are a lot of reasons for a node transitioning to not ready. Many of those might not have any impact on whether or not the application can actually service requests networking wise. And if that is not the case, I'm kind of looking for people's opinion on maybe adding a knob, so an annotation on the service object, to be able to disable the node readiness impact on the reconfiguration of the load balancer. And this would again be useful for applications which are experiencing a high intensity or a high load, so to speak, because in those cases, the thing that might be crippling the SLA is the kubelet and not the actual performance of the application. And then I was kind of thinking about this even further, and I was imagining things a bit the way health check node port works currently for ETP local, which is to say that probe is configured on the load balancers and that actually targets a node port endpoint on the node, which returns a status code to it. So why don't we do that as well for what concerns the node readiness state, which is to say that in this case, the Cloud LB would target the same endpoint, but the endpoint wouldn't just return an HTTP 200 if the endpoint is running on the node. It could also interrogate the Cubelet's read-only port. And because the Cubelet is the one that actually sets the readiness state. And then going even further beyond that, I kind of imagine also aligning the behavior for all types of services. So not only ETP local. So cloud providers perform health checks in different ways. Today, they're a bit sporadic and it's not really well aligned. So maybe the proposal here in the future would be to write an enhancement proposal for all of this, which would kind of align the behavior for all different types of services. Now, for each proposal, I kind of wrote a problem with it. So for number one, I don't see any. That might not be true, but for the second one, node readiness has no impact on routing decisions for the LB, but maybe it should actually be the case. So maybe the current implementation is actually correct. So for discussion, for number three, I think obviously we need an enhancement proposal and a sign off for this. But given that CNI plugins can implement health check node port themselves, I don't really see if there's any possibility to force CNI plugins to use a specified implementation for how it is supposed to work. I just checked before this meeting. Cilium, for example, is using a specific method or a specific server, so to speak, for the health check node port, whereas kubeproxy obviously is using the standard implementation, and OVN Kubernetes, I'm only saying it because I used to work on it, uses kubeproxy's implementation for that server. But could we align all of them? I'm not sure. And then obviously number four is even more difficult because that has impact on the cloud provider implementation for all of this. Yeah, so this is kind of the problem that we're facing on this project, and some of the ideas I've had surrounding it. Feel free to tell me if you think anything's crazy. I see somebody raising their hand.
Hey, thanks for that great exploration. I have in the past spent some time thinking about this too, and I have some thoughts. I know Bowie is here too, so he can actually speak in maybe more details. Some of the things you identified, especially in the first part, I think are bigger than you're even describing, because some implementations have limits to the number of backends that can be behind a single load balancer, right? Like they're designed for VMs, not for containers. And like the Google load balancers, we have to pick a subset of the available nodes in order to put them behind it. So we have a separate implementation. Cloud Controller Manager makes it possible to have different implementations, right? And so we have a separate implementation which tracks the sort of most ideal subset of nodes to stick for a given service. So for ETP local, we're going to choose nodes that have a backend, and for non-ETP local, we're going to choose some subset of nodes. And also because, sorry, Boy, why don't you just say?
Oh yeah, I was going to say that in our implementation, we do a subset of nodes, so you might not run into this problem because it's not all nodes, all LBs.
Right, there you go. There's also things like programming time, right? Like there's propagation delay, like you suggested. So you don't want to be flapping if you can avoid it. You raised the topic of resource starvation on the node, and I'm torn on this one, because on the one hand, if your app is starving out the Cubelet, then the Cubelet is clearly under-resourced, like it shouldn't starve, right? On the other hand, it's very dynamic, right? The Cubelet doesn't always know what resources it's going to need in order to service all possible applications. So I'm not sure what the great answer there is yet. The last part, removing the suggestions. Well, first, can you clarify, when you say don't sync not ready to ready, do you mean don't publish that on the node, or do you mean just don't use that to change the service endpoints?
Yeah, I mean, don't update the LB, the cloud provider LB, with the new set of nodes, right?
Okay. So yeah, this is where I had spent most of my time thinking of how can we do this, because there's a second part of this. Some of the load balancers, if you remove a node from an endpoint set, any open connections will be killed. Whereas if you leave it in the set but fail the health check, the connections, there will be no new connections, but the existing connections will be left alone, right? And so today we do the worst thing, which is every time a node comes or goes, we just, or rather, every time a node becomes unschedulable, right? Which isn't even to say the node is unhealthy, just that it's being cordoned, right? Like it's going to be drained. Say we're going to do a 6-hour drain. I set unschedulable on that node. Any traffic into that node will get killed. That's not what we want, right? What we really want is to say, there's a conditions where the node is in the set, but not accepting new traffic. And there are conditions where the node is out of the set, right? Very similar to the discussion we've had over the last couple of meetings about graceful endpoint draining at kubeproxy. We have the same problem here at cloud load balancers. And we haven't done a great job making this life cycle possible. So some of your ideas here are interesting to me. Some of them seem impossible. Like I don't see how number 4 could actually work. Number 3, we could actually do the inside kubeproxy. Like we could make the health check node port not just return true, but actually dynamically check kubelet at the same time, right? That helps kubeproxy. It doesn't help other implementations, but we could at least say, hey, we think this is a valuable change.
I have a question on this. The intent of this is to replace looking at node ready, unready by just checking kubelet directly?
Yes.
Okay.
That would be by the CCM, So the CCM would only update the LB whenever a node gets added or deleted, so that the LB has the full set of nodes, but it wouldn't care anymore about transitioning readiness state, so to speak, because the kubeproxy would do that now by interrogating the kubelet port instead. It would be more dynamic, essentially.
What's the status now of the CCM? I thought that the idea was to get to move to independent CCMs and not to use anymore the in-tree CCM.
There's still a framework of code that most of the CCMs are starting from.
It's
like
not
the existing controllers still exist. That code is still being used, but now everybody's building their own binaries for it.
Right, that's what I'm saying, is if shouldn't be easier to create its own CCM.
Oh yeah, this cloud providers should be able to and are encouraged to find clever answers to their own problems.
I'm not very familiar with any of this work. You'll have to excuse me. In our case, for example, you could imagine one case where we're running on GKE. So the GKE runs the control plane for us, but I believe they just use the CCM provided by Kubernetes, right?
Yeah, we're like everybody, we're in the process of converting to a Google specific cloud controller manager, so that we only link the Google code into it and not all the other cloud providers. And so that we have a clear ownership and ability to, do stupid things when we need to.
But for what concerns the service control.
Sorry, go ahead.
Yeah, for what concerns the service controller part, so this node sync loop, so to speak, that would continue to exist even in the Google implementation, or maybe not? Maybe that's a secret.
We've already got a variant of it, right? Bowie, does that live in the, which binary does that live in now?
It lives right now spread out in certain repos that are now badly named, such as Ingress GCE. I think the general idea is that instead of converging implementations in the code, it's a convergence on APIs from a cloud controller manager perspective. Like your load balancer implementation could, in fact, like have like a completely different control loop if that makes the most sense. Because we found historically that the previous method of like trying to make it very generic in the code from an interface standpoint just ended up not really working out very well in all situations.
For exactly these sorts of reasons.
Okay. So kind of a corollary question to this entire discussion is, at least for point one, given that this is an issue that this project is currently experiencing at scale, could it be considered a bug? If it's considered a bug, is there a possibility of having something like this actually being backported to older versions of Kubernetes? But maybe that's a discussion for that PR instead.
I haven't seen the PR. Is that the one you linked here, 109.706?
Yeah, exactly. I just filed it this morning, so.
Okay. The other thing that you need to check, Alex, is what cloud providers are you targeting? Because I know that some of them are using the out of tree controller manager. I think Andrew is not here. No, Andrew Saikin is in C Cloud. But
I'll have to look at this PR, but looking at the description of it, wouldn't this mean you need to have a watch on pods?
No, in this case, not. I didn't see the necessity for that, because this is only handling ETP local, so to speak, and so you're just provided the entire set of nodes that exist in your cluster, and as long as that is synced, the health check node port will actually tell the LB where the endpoint is. So there's no reason to watch endpoints or pods and check if they're being scheduled on other nodes and whatnot.
Sorry, looking at number one, you're saying for services that are ETP local, do not sync if it does not have service endpoints. How do I know in the service controller whether you have service endpoints or not?
Oh, right. Yeah. I use the endpoints lister. So to get the
and you depend on the metadata in the node, whatever the node reference field.
Exactly. Yeah. That's maybe not a good idea. Maybe not.
Yeah. Well, just pointing one thing out, you need to use endpoint slices, by the way.
Yeah, I was hoping that this might get backported to versions that do not have endpoint slices, so that's kind of why I didn't do that. But yeah, obviously that is the right way to go forward.
So if we were to draw out the sort of state machine of nodes with regards to load balancer traffic, right? We have at least node doesn't exist, node exists but is unschedulable, node exists but is not ready, and actually the crisscross of those two, right? So there's 4 states there. And then, well, like I said, it covers node exists and is schedulable and is ready. And I guess the question is, do we want to change the behavior on certain edges, right? Is that a fair assessment?
Yes, I would say so. In this case, what is kind of shooting us in the foot is no transitioning from ready to not ready and back again, so to speak. So the schedulable part is not really the big pain point with clusters at scale, and especially with these CPU intensive loads that we're running and all of that.
Right. And the problem here is that ready and unready can either mean, hey, the kubelet went out for a long lunch and didn't come back, Or it could mean this node has powered off and we don't know yet, but this is our first indicator, right? I guess in that case, if we're relying on health check, then the health checks will cover it, right? If that's the assertion?
Yes, definitely the second one, yeah. Well, where the machine has actually powered off, so to speak, because you wouldn't have kubeproxy reporting back the status to the LB either.
So I would need to go back and do some spelunking. We need to make sure that in the non-ETP local case, so when you have a regular old service, that we don't continue to send traffic.
I didn't touch that case at all. So the implementation only focuses on ETP local.
Yeah.
So that's what the change concerns itself with. For everything else, it remains the same as it currently stands.
Sanjeev, you want to ask your question out loud?
It's just a naive question. Is this implying that they aren't existing in ops enough to protect Cubelet from abusive workloads? It's a more general problem.
This is what we're seeing. I mean, you could protect it by setting resource limits on your pods, right? But we don't want to do that.
Well, you mean protecting me by having you set limits is fragile, right? If we need to set the appropriate request for Cubelet, make sure that Cubelet is getting enough shares that it can always service what it needs, right? Okay. This is the whole like allocatable problem, right? If we carve off too much, then we eat a lot of your node that you might not be using. And if we carve off too little, then you have this.
So I might need to do some spelunking and see if we set those parameters correctly for the Cubelet on our end.
Yeah, that's a good thing to check.
Yeah.
Because allocatable comes off the top, right? Like if the node is 8 cores and you say allocatable is 7, then Cubelet's got 1 to mess with. It's supposed to anyway.
And not just resources, but also scheduling priority for the Cubelet process. We should document all the options and best practices to ensure Cubelet is always protected.
That's a good point. I'm fairly confident, not sure, fairly confident that SIG node has got some of those things documented. I wonder if we can do a better job, or maybe this is a good catalyst to go and like relook at those things and make sure that we have a new thing for them to consider: network abuse.
Just the last thing I wanted to discuss was the possibility of doing 2A, which is to say that you annotate, that you have the possibility as a user to annotate the service object, which tells the CCM to completely ignore node readiness checks at all. So the CCM will only think the addition of a node or the deletion of a node for what concerns the LB, and the LB associated with this service, if it transitions to a not ready state, the CCM doesn't really care about that. It will just keep it configured as it was. How about that?
That's really my least favorite option. We have so many of these little fiddly knobs that force users to understand our implementation details. I would put that at the bottom of my list of things to prefer. I'm personally trying to figure out if we can do something like 1, but not even consider whether you have endpoints or not. Just change that edge. Like maybe that edge doesn't make sense. Maybe we should lean more on health checking and just ignore the ready, unready, schedulable, unschedulable differences. That's where I was headed. I actually have a branch somewhere that started to implement some of this in kubeproxy, and I realized it was getting a little bit complicated with all the health checking. And then I got busy.
So what is that exactly? I didn't fully follow
along.
What
if we just did something like what you describe in 1, but we just always ignore ready, not ready, and we rely on health checking, and we say, like, there needs to be a health check for regular old services, and there's a health check for ETP local services, and those might not be the same health check, but we just don't change the set of backends except when nodes are added or removed, which I think is what you're getting at, right?
That's point 4, though. At least I did a piss poor job at maybe writing it down, but that's my idea behind point 4, which is to say that we have a health check node port probe by the LB, and the cloud provider already, or the cloud implementation, so to speak, already defines a probe as well on the LB for regular services of type load balancer. But these probes, they never check the kubelet state, so to speak. So why couldn't they do that?
Okay, so I misinterpreted 4. So the way I read 4 was have your health check do 2 probes, which, like, there's no way I can convince the cloud load balancer to do that, right?
No.
But I could and it myself in kubeproxy, right?
That's what I was getting. That's what I wanted to do. So my plus sign, at least on point 3 here, my plus sign is and. Sorry. Well, it wasn't really. So HTTP 200 if endpoint is running on node and kubelet is reporting okay, and the thing doing this, so checking that, is kubeproxy. So kubeproxy would check the endpoint as it currently does, and it would also do, I don't know, curl 127.0.0.1 kubelet ready only port, read only port, sorry, is it okay? And then returns an answer to the LB. So it's ANDed.
Okay, I'm gonna have to read your PR and think about that. Anybody else? I've been doing all the talking.
I didn't mention it on the PR, but I'll put a comment on it, maybe summarizing kind of these ideas that I have in this presentation, hopefully do a better job. And
I think it would be good to confirm that you've set all the available options to prioritize kubelet.
Yeah, definitely. Thank you for the pointer, because I didn't check yet, and possibly we're maybe not doing it right. So.
But that doesn't mean this isn't actually a problem.
Yes, that is kind of, yeah, that's more for point 2 here, which is to say resources are starved, right?
Right.
But yeah, the time to sync LBs is definitely still a problem, because when you have so many LBs on a cluster, the cloud provider can either rate limit you, or it just takes a ton of time to sync. And you start.
I would also say you should go look for the Google Cloud internal load balancer subsetting logic, which I think is, like Bowie said, I think it's in the Ingress GCE repo where we do it a separate control loop. If you can't find it, we'll help you find it. But you might also consider doing that and just saying, I'm not going to sync all my nodes. I'm going to sync some subset of them.
Okay. All right.
Great. Should we move the rest of this discussion to the mailing list or the PR or both? Where do you guys think is best?
PR, and if we overflow to the mailing list, I guess.
Perfect. I'll put a comment detailing kind of these other options on the PR so that we can take it from there. And I'll give people a chance to read through and think it through as well, because it's not always easy.
For the record, I assigned myself so that I don't lose track of it. That doesn't mean I'm committing to work on it yet.
No worries. Thank you.
Thanks, Alexander. Antonio, you were next on the agenda.
Yes, this is because yesterday I don't know how, I think that Containerd people wanted to add a release note saying that the CNI was going to break, that people had to get a migration path and something. And Casey Calandrello, I think that Casey Calandrello is the name, fixed the problem. But I'm not really sure. Well, this wanted to say that for the CNI plugins, this was going to be a nightmare because they wanted to do a blog post, a big announcement saying that everything was going to break, and but what I'm not sure, and I was expecting Dan Williams to be here. If this was really a bug for containerd and cry or a bug in the on the CNI plugins, because the ones that parse the CNI configurations are the CNI plugins, right? So the bug was like this: is when you have a CNI configuration without version, if you are using CNI greater than 1.20, it parses the version as unknown and it failed to delete the interfaces.
Huh. But
So
that's
what
fixed now? Was that the summary?
it's fixed in CNI library, and containerd folks thought that it was a problem for them, so everybody in Kubernetes had to agree. But what I'm not sure if is this a problem for containerd, because they are doing some kind of Kubelet thing for testing, or if it's a problem for CNI plugins. So that's why it's a heads up for the CNI vendors to check this, because if they are using this 1200 as library, they may have customer clients or people failing after the grade, or I don't know. It's a convoluted problem. I just got into that yesterday by chance, and thankfully we were able to solve it, because this was going to create a lot of noise, and that wasn't really a noise. But for example, Calico and all the people with CNI should check this.
Yeah, I had seen this thread, but hadn't yet had a chance to read through all of it yet. So it's definitely on my list. If I understand what you're saying is just that it's in the CNI library failing to parse configs that don't have a version specified.
When you use the after 8080 or something like that, if you don't have a version in the CNI config, it returns a -1. And before it assumed that was 0.1.0. And that was the breaking change. And Casey fixed that yesterday. And now in 1.10, it keeps assuming that is 0.10. And what the containerd people find out is that that was breaking the CI. But I think that is because they are not using a CNI plugin. They have some sort of Kubelet hack for testing. But I really don't know. But I just want all of you to check, because I don't want, I mean, it's going to fail on users because they cannot delete interfaces or something like that.
And did you, wow, this is complicated. Does this containerd folks have an opinion on this?
I stopped at them because they were creating a blog. They were creating release notes. I mean, they were creating a full announcement about that everything was going to fall apart in 1.24 with the CNIs, and I couldn't believe it. And that's why I pulled Casey in the morning, and he found this regression, and then I went to bed. I didn't do anything since yesterday. So when I wake up, I say, but this is impossible. Containerd is not parsing the CNI configuration. So that's why I want people with CNIs to check so they don't hit this bug.
Okay, well, Casey's got it on his radar. I don't think anybody from Cilium is here, are they? No. Antria folks are here, yes? No, yes? Somebody make noise?
Yes.
All right, cool. Consider yourself notified. Is there follow-up, Antonio? Do we need to come back to this, or is it sufficient to
For-
say the ball's back in their court?
If somebody finds out something, that just share it in the channel. I mean, everything went silent, so I assuming that everything is okay. But I was surprised that people didn't, warn us before. I mean, they were preparing a blog and release notes and everything, and considering us.
Well, thank you for catching that.
No, I was lucky. I mean, because somebody been in the Signalboard channel. I think there was Tim from the guy from SIG Talks. He always pull us. Oh, well, that was all.
Cool. Thanks, Antonio. I'm just looking at those PRs now. I'm pretty sure we've already updated, but I'll double check that. Who's next? Sanjeev, you're next.
Okay. How much time do I have? Because it's probably
There's only one thing after you, and I think it will be pretty quick because it's just a meeting time discussion. So
okay. So we'll give it a go. It probably needs more time, but we'll see what we can do. Let me share some slides.
Do we want to just quickly do the meeting time discussion first and then
Yeah, go ahead.
you can have the rest?
Yeah, go ahead.
Sure. Mine's, like you said, very simple. I wanted to follow up on that mailing list thread that Tim started back in the day. Specifically, the idea was, hey, can we move this earlier so it's more accessible to people who want to attend from Europe? I summed up the responses on that thread. The most popular response was either of the suggested times. The suggested times were 9 and 11 a.m. Pacific time. It seems like 9 a.m. very slightly won out over 11 a.m. I tried to add a table in the agenda just with those numbers. So based on that, I would suggest just moving it to 9 a.m. if there's no objections. Does that make sense?
And this is, it's still going to be Thursday?
I would, I don't want to overcomplicate this, so I would say same day is going to be easier than trying to find a new day too. But if that is problematic, we can figure something out.
Am I the only person who has been in solid meetings because it's Thursday for like the last 7 hours? I mean, okay.
No, I am too, but I would do my damnedest to move things around because this has a larger attendee list.
I mean, some people, including me, may have overlap with Helm, which is at 9:30 a.m. on Thursdays. So I'm always going to be juggling that. But if that's just me, then.
Is that a weekly meeting? Is there a way we can do like alternate?
Yeah, it's weekly.
Okay.
Can this be 8:30? Does everyone hate that? All you Pacific people.
My biggest concern is I like having the hour open before this to prep and do stuff. So 8:30 makes that exceedingly difficult. But if that's where we land, I'll try to figure it out.
I mean, 9 is fine. It just means I might duck out early sometimes.
Well, didn't you hear Helm's been killed? Kidding, I'm kidding.
I mean, I heard that we're all going to the smallest possible web assemblies, right?
That's right.
Everything on the edge, no more computers, only Raspberry Pi.
ASICs.
Perfect. Well, I'll send out a mailing list update on that thread with the assumption of moving to 9 a.m. on Thursdays, starting after KubeCon.
I'll move the meeting.
Okay, great. And I'll give the time over to Sanjeev. Thanks.
Okay, thanks. Okay, so yeah, I've put this link to this doc in the mailing list. So obviously we won't be able to go through most of it right now. Just wanted to introduce it and have you all look at it later and provide comments. This is something that's relevant both to SIG network and of course SIG network policy and SIG multi-cluster. It kind of straddles these areas. So hoping to come to a resolution there and deciding how to take forward multi-cluster network policy. Let me do this. Yeah, okay. So I'm not going to go through this, but there's some requirements that have sort of made sense to me and based on discussions with others, but by no means are we done with being sure of the exact set of requirements. So here's a working list of requirements that, I've put together based on some discussions with some of you offline as well, but we need to keep working through that. But in addition to, but there's at least a few use cases that are more obvious than others. So we can get going with those use cases and we can decide whether we want to add, delete, modify. There's a lot of stuff here related to, single network models, multi-network models and things like that. I'll let you take your time to read through it. We might need to have another call to kind of go through it in more precise detail. And there's sort of the big questions as well, which is, how critical is it? Do we even need multi-cluster network policy? If we do need it, is the priority high, medium, low, or never? Should we design this to cover various kinds of multi-cluster deployment models, like what is frequently called single network and multi-network modes of operation? Should all the features work in all modes, or is it okay to identify and some modes are more important than others? So for example, design some features that only work in single network mode. Should this feature be limited to reference architectures defined by the Kubernetes multi-cluster services API model, right? Which is what the SIG multi-cluster is doing, or should it not consider that as a boundary? Should it, feel free to go with beyond the multi-cluster MCS API model. I apologize. Some of you may or may not be all familiar with the MCS API model. I'm presuming many of you are. And then, a lot of these are very analogous discussions that happen both in SIG multi-cluster as well as in other kinds of multi-cluster networking projects, including, for example, Istio multi-cluster. For example, you can have Istio meshes, which can themselves have a single network or multi-network deployment model. And then you can have federation across meshes. So the analogous sort of topologies come into play here as well. And then a little bit more clarity on requirements on the trust model across clusters. Is it, namespaces which are global, and there's a little bit more that needs to be worked out on the requirements. But having said that, one can reasonably put together some reasonable use cases. So let's just go through real quick, and you can feel free to provide comments later. One is, okay, I want to be able to control. I'm going to be using MCS terminology here, multi-cluster services API. Forgive me if you're not entirely familiar, but it should be fairly clear from the pictures. So I want to control which pods in a cluster are allowed access to a service that's been imported from another cluster. Okay, so here I've got cluster A. I've got 2 pods. I want to be able to flexibly control that pods which fit into category P1 are not allowed to access this remote service, right? So, okay, context here is that there's this remote service running on cluster B. It's a multi-cluster service, and it has been imported across the network, which is an arbitrary network, maybe single network, maybe multi-network. And since it's a multi-network, it probably requires a gateway, which is what I've shown here. And allowing for all these different models, I still want to decide how some pods are allowed to access imported services and some pods are not allowed to access imported services. So that's use case number one. You see here, it should ideally work in both single and multi-network. And it appears that we should be able to do at least this kind of use case within the current MCS API, right? One example of doing that would be fairly straightforward. In a network policy, which could be either a new version of an existing network policy or might even be a new kind. That's another discussion. For now, just let's not worry about the kind, let's just worry about the selectors. So in this case, something like, okay, just having an additional kind of egress destination, which is basically a service import or a reference to service import, can allow you to configure that these pods, which are selected by this policy, are either allowed or not allowed to egress to this imported service, right? So that would be an example of a sample manifest that satisfies this kind of use case. Another use case, I'm just running through a little bit. So, I'm sure there's questions. We'll maybe just take 2 minutes at the end to provide some high-level thoughts. Or maybe I can pause after this use case, and if you have any questions, you can comment right now. Use case B is I want to control on cluster A whether I can access a service. If the same service is provided by multiple clusters, like in this case, MCS foo is provided both by cluster B and cluster C, but I want to control and on this cluster say that when this client accesses this multi-cluster service, I only want him to access it through this cluster and not through this other cluster, okay? And again, I would ideally want this to work both in all kinds of topologies, including single network, multi-network, flat network, and so on. It would appear that we can do this without changing the current MCS API with a few assumptions. The assumptions could include the fact that if you're running this in multi-network mode, the combination of gateway IP and cluster set IP must be unique per export, right? So that and what this would do is that every cluster that is exporting this service would attach the appropriate labels to allow the importing cluster to decide to put in its data plane only destination. You can say that, okay, if this cluster is exporting MCS foo with the label of color equals blue, and this cluster is also exporting MCS foo, but with the label of color equals green, then you can have a policy in cluster A which says cluster A clients of this kind, when accessing multi-cluster service foo, can only access it from clusters with the label color equals blue. And so in order to distinguish that in the data plane, you have to have this assumption that the combination of the gateway API and the cluster set IP are unique, so that you can differentiate that in the data plane. Some of it may not be entirely obvious. We can spend more time if needed thinking about it. So there's a few more use cases. I could either pause here for any comments or keep going.
Got 2 minutes left, so probably a good time to pause and get any comments.
Sanjeev, I do have a quick question, if you don't mind. So in terms of controlling, which service endpoint in which cluster that a client can access, is there a specific scenario where this might be useful you have in mind?
You're referring to this use case, which is currently on the screen, or the previous one?
No, the previous one.
Okay, this one right here?
No, I think use case B, I guess. Controlling this, this one.
Okay, so here, this was actually suggested to me by Nathan Mittler from Google. What he said was that, very often a service would be provided by lots of different clusters. It'll be given the same name, but you may have policy regulations which tell you that, okay, this cluster should only access this global service from clusters located in the US, for example, and not from clusters located in Asia Pac or things like that. So you want to name the service the same, but you want to control which backends you are allowed to access that service from and which not. Now, the most general version of this would be to be able to control on a per backend pod. That would imply it is always a flat network model where all pods are globally unique and it's all running on one network, and this whole thing is working exactly like one cluster. Since our initial assumption is it should work in all topologies, including multi-network, our granularity is on a per cluster basis. So anyway, the short answer is the use case was, I want to be able to administratively control whether I can access this foo service from clusters located in North America versus clusters located in Asia.
Right. I understand that part, but I guess my question was more in the lines of, in that specific case, why don't we just put cluster A and B in one cluster set and put the South America or whatever clusters in another cluster set, so that those are not aggregated to begin with? But I do acknowledge this is teaching the user how to do such things, which might not be ideal. But this is just my
well, we don't want them. They may have good reasons for, we don't want to force them to always create more clusters in order to solve a problem. In some cases, if that's the only option, then yes. But very often it would be that restriction applies to pods of category P2, but pods of category P1 may want to access a global service across all providers of that service, wherever they are. And they're both located on the same cluster. So yeah, you can solve network segmentation by just creating separate disjoint cluster sets. But sometimes you want to have shared cluster sets, but partition within the cluster set. But yeah, your input is welcome, and we should discuss how relevant these cases are. But there was some.
I'm skeptical. Personally, I'm skeptical of that use case, but I want to hear more. I see that we are at time. You should put yourself first on the next agenda.
Okay.
And say 30 minutes. I need 30 minutes.
Okay.
Yes,
yeah.
Agreed.
Oh, the next agenda will be canceled, I guess.
Yeah,
well, no, you can have it, but I won't be there.
It has already been removed from the calendar.
And include some links to multi-cluster stuff, so people who haven't been paying attention to that can get some understanding of multi-cluster in general, so that we can understand how multi-cluster network policy fits on top of that.
Yeah. The main thing is the KEP for the MCS API, but I'll add it. Yeah. Okay, thanks. We'll discuss more on the next call, and also feel free to look at the doc until then.
Thanks, Sanjeev.
That wraps it up. Thanks, everybody. See you not in 2 weeks, but in 4 weeks at 9 a.m. Pacific.
Or at KubeCon.
Bye.
Or KubeCon, yeah.
Bye-bye.